So we're going to look at another example of regression. Healthcare costs are a major topic in the news today. I have some older data here from the NEH fact sheet from the Center for Medicare and Medicaid. I'm going to, when we walk through this example, use some more updated data. But as you can see here, in 2002, it was around $5,500 per capita per person for healthcare expenses. I'm going to go over here to my Excel file, and we're going to look at this example. I went and got some updated data. I changed these instead of listing, 2013. I'm doing years since 2000, so 13, 14, this is 2013, 14, so forth and so on. Healthcare costs in thousands of dollars by 2013. It was up to $7,706. And you can see the cost going up as well. Again, if we were kind of doing this by hand, we're going to take our x value here. So we'll have equals, got our x value here, and then we are going to square it. So 13 squared is 169. We're going to drag that down again so that we have all of those x values squared. We're going to square all our y values, so same thing, equals, we'll grab our y value, caret 2 for squaring there. Again, we'll grab our little box there, drag it down, and then again, x times y, we'll just pull x times y. And then again, drag that down as well. So we have all the values that we need here now. And then again, we'll kind of draw the line under here so that we know we're done. And then we're going to want to find the sums for each of these. So we'll grab all of those. So sum, or you can use the sum function and grab all of those points. And again, we'll drag this over because we want all of these sums. So if we're going to calculate this by hand, again, we'll start off with equals, we'll do a parentheses because we got that whole numerator. We have 6 data points times the sum of x times y minus the sum of x times the sum of y. So there's our numerator. And then divided by our denominator is, again, parentheses, and then we've got 6 times the sum of x squared minus, in parentheses, the sum of x, and then we want to square that. And that gives us a 0.3444. That's our slope for our regression line. And then again, if we want to find b, then I'll start off with equals again. We need parentheses again because we got that numerator, that whole numerator. We want the sum of y minus our slope that we found times the sum of x, and then we'll close our parentheses, and then we'll divide by our number of data points, which was 6. So in this case, our slope, our intercept is 3.24. So again, if we're going back to the year 2000, then our intersection point there would be about 3.25 essentially. So our whole equation, we can go back over again with our updated data. So again, our updated data we end up with y is equal to 0.344 x plus 3.25. Again, this is in thousands of dollars. If we want to check our work here, then we are going to go over to insert. Again, we're going to grab our x and y values here. We're going to make our scatter plot, which is right here. It puts them over here since we don't have the 0 there. It starts at 13. Again, we're going to right-click and add trend line. And again, we want it to be linear. If we, at the bottom here, we want to display the equation. on the chart, and you can see here that we end up with that same equation that we talked about. We've got our slope is 0.3445, our intercept is 3.2492, so we did it correctly, and we've got our chart here then too. So we've got our equation now. Again, we've got our slope and our intercept. So we can use the least squares line estimate to figure out what the per capita healthcare expense are. So we can use this in either direction potentially. So if we want to find out what the expenditures were in the year 2011, again, this is going to tell us that x is equal to 11. We can plug that into our formula. So we have y is equal to 0.344 times 11 plus 3.25, and you end up with 7.034. Again, this is thousands of dollars, so $7,034. If we go over to the actual chart here for 2011, would be this column here. I have the per capita highlighted down here. It was actually $72.90 in this row here. So again, close. Again, it's an estimate that we're using here. So we're off by about $250 in our estimate. Let's just do another one. Let's say, what is the price per capita going to be in 2021? I want you to pause the video here and see if you can find the estimated cost next year in 2021. So hopefully you ended up with $10,474 as your estimate again. So pretty high. Then we've got one more question that kind of goes along with this here. We want to use the least squares line to estimate the year in which the per capita healthcare expenditure would be $12,000. So in this case, we have our y value, but again, it's in thousands of dollars. We have 12 is equal to 0.344. We want to find x plus 3.25. So if we go through and solve that, we're going to subtract the 3.25 from both sides.